Well, hello again. In this video, we're going to be talking about artificial intelligence and how quantum computing enhances the capabilities of artificial intelligence. So, if you're interested in this topic, stay with me for a little while and you're going to learn everything. There's not much on Google, there's not much on internet. Actually, ChatGPT hallucinates. I will show you if you want. If somebody sends a comment in the video, I will tell you how ChatGPT doesn't know this knowledge. Google doesn't know this knowledge. This is very technical work that you need to refer to technical papers in order to understand it. And the reason why I'm recording this video is that many people struggle to understand the mathematics and the technical aspects of quantum computing. And I explain only the part that I understand because I'm not in physics, I work in cybersecurity. So I'm looking at how quantum computing improves AI capabilities from the perspective of how future AI would be very difficult to maintain. We don't know what the future holds with artificial intelligence, but once you combine artificial intelligence with computing power of the quantum computer, it's very likely that this will surpass the intelligence of a human brain, so AI would be smarter than us. And what is the timeline that we're looking for this? We're looking between 5, 10, and 15 years time that we're going to have a quantum computing. And once we combine that quantum computing power with AI, we're going to have artificial general intelligence. And is that going to cause the technological singularity event? I don't know, but it's a possibility. Technological singularity event, it's an event that artificial intelligence surpasses the human intelligence and causes big problems for the humanity. So that's the topic of this video today. We're going to be looking at how AI and quantum computing can be linked together. This is part of my course with Pearsons and O'Reilly. If you want to watch the full course, you can subscribe. You can sign in if your organization has a subscription. Most organizations have it. People don't know, but Google, Cisco, and most universities in the US and in Europe, they have a subscription to the O'Reilly Digital Library. Once you click in and once you log in, you realize that you have that subscription, then you're gonna know for life. There's loads of courses that you can watch over there for completely for free if your organization has a subscription. So you can just type my name in the search engine here and you're gonna see all the courses that they're coming up depending on when you would see this video, because if you see this video after 2nd of September, then clearly that course would be over. I think they record them so you can get them on demand, but the whole idea of Pearsons and O'Reilly courses is that you see the new things as they happen. Technology changes fast, nothing stays static. So I have another course on the 10th of October. This is on agentic AI and cybersecurity risk. I have a different course on 15th of September. This is on the top 10 most risky aspects of AI. And I do have multiple books. So this is a book on post-quantum security. I can show you some really technical books. My book is completely different. It's explaining how artificial intelligence could cause the technological singularity without getting you into a stage that you want to kill yourself because it's too technical. A little bit more about myself. If you want to know more about me, I work for the University of Oxford, the Department of Computer Science. This is my profile. I've been there for 10 years, possibly longer. I've lost count. So let's start with the course that we are meant to do today. That is AI and quantum computing capabilities. Let's see what do I have prepared on this topic. So this is all the articles that I have, and I'm gonna open them all, and we're gonna start looking at these technical papers and practical solutions. So in the previous, by the way, if you want to see the whole thing, this is my preparation for the course. It's gonna be like a playlist, and you're gonna keep getting new videos every day if you subscribe to the YouTube channel. In the last two videos, we did more technical work on looking at technical papers from universities. We're gonna have less of that here, but we're gonna have more of GitHub repositories. So we're gonna have the actual code, the actual solutions. We're gonna be looking at how this is applied in practical scenarios, things that you can do today, not things that you would be able to do in 10, 15 years time. But quantum computing, it's already on Azure. So starting from an overview, looking at an overview of quantum computing and its application in artificial intelligence. Here is an article that has been viewed 2,500 times. So this is one of the articles on IEEE. I'm not the author. Let's see if we can get it. No, you have to pay a subscription for this. So I'm sure that you're going to be able to get it as a preprint if you wanted to read this. But again, I showed you how to do that in the last two videos. I showed you how to get without paying the subscription fees, and it's perfectly legitimate way of doing it. You watch my last video and you would know for life how to get free access to these journal papers. And it's again, I'm putting this on video camera. I work for a university. It's not a dodgy way that you go and bypass some settings. You are actually reading at the preprints. So when this is printed here, it has the formatting of the journal, but if you do it without the formatting of the journal and you submit it as a preprint on Archive, it's the same text, the same article, just without the formatting, and it's perfectly legitimate way to use it. So here's a different survey. This is a survey paper. Let's talk a little bit about what is the difference between survey paper and a research paper. Survey paper, literature review papers, those are just reviewing information that is already existing. Research paper is when somebody is actually conducting groundbreaking research and producing new knowledge. This paper, it's a survey paper. It's surveying what has already been published by other authors. So it's an interesting paper. You can read it for free. It has loads of different diagrams, and I have covered it in one of the previous videos. So I'm not going to go into more details, but just remember there's a lot more information that is publicly available that you can possibly read. So let's look at this one, a review of quantum cybersecurity threats, risks, and opportunities. Let's see. No, you have to purchase, and to purchase this, you have to pay. As a non-member, you have to pay £35. Let me just try to see if I can get this one for free. Let's see, Google review, ResearchGate, there you are. That's a preprint on ResearchGate. So you can read exactly the same paper for free on ResearchGate, published by the author himself. So that's just a quick demo. I'm not going to go more into that. It's going to get really long. Here is another paper, Artificial Intelligence and Machine Learning for Quantum Technologies. I think physical review, it's not an open source, so we have covered this paper as well. So I'm going to close it. You know how to get these papers and how to read them for free. Now, moving on to more practical applications. We're looking at the IBM now, technology for the future. What kind of technology stack you can get from IBM? So this is a Qiskit function. So those are various different aspects that you can, those are different chips that and works that you can get from IBM. But this is interesting. This is interesting here. Quantum computers, view pricing plans, open plan. So you can sign up and you can get it for free for up to 10 minutes of runtime per month. Now, IBM has a quantum computer. If you don't know, there's various different quantum computers. IBM has one. Microsoft has a chip. Google has a chip. There's various different ones. But here you can get it for free for up to 10 minutes per month. So if you're one of those enthusiasts that you wanted to experiment with quantum computing, even for this you don't have to pay. Obviously, if you're working in this field, your organization will pay these premium plans, which will be 48 USD per minute, or even this one, pay-as-you-go plan, 96 USD per minute of using it, but here you're getting 10 minutes for free. Most people don't use it. So imagine that this was your pay-as-you-go plan. You're getting £960 for free to test this technology if you wish to do that. So I'm not going to say any more on that because I don't sound like I'm advertising IBM. I'm not. I don't work for IBM. They're a good company and they're giving these things for free. Most people don't know that they can get this for free. It would cost you £960 per month, and you can get this every month. So it's not like a one-off. They're trying to get money from organizations that they have money. They're not trying to get money from people like you and me that they wear £5 t-shirts. Okay, this is from Google. This is an open source framework for programming quantum computers. Now, I just wanted to highlight this section here for you to see it. How does that look to you? This is just a simple code. So if you think it's that difficult, it's not. You can click here, you can go to the GitHub repository. Actually, this is the GitHub repository, and you would have full access to all the different instructions over there. But It's as simple as you open Python or C++, import, and you import this. So then you can start working with this. If you're interested in working with quantum AI, there are some solutions that they are already there. This is the world leading. Google is one of the leading institutions that has this. So you have options. You can start playing. If you think, I want to learn Python, okay, I'd never used Python, or I want to use C++. What would you use? Print hello world? Why don't you print something more useful like this? So start, if you start learning how to use programming language today, just the advice, it's not, AI will take over that part of the workflow, especially for the beginning, the very repetitive, tedious tasks. AI is already quite good at doing that. So GitHub Copilot can be integrated with various different agents, and it can produce code much quicker than most people can. So if you're going to learn something useful, learn how to use quantum AI, and it's a simple function as this: import, and it's imported, and you can start learning how to do that. Okay, closing that. TensorFlow. Just so I don't sound, actually Google uses TensorFlow, and TensorFlow is mostly C++. It's not that much used in Python. PyTorch is most frequently used in, but it depends. You need to use both. It's not like you use one. It's good to learn how to use both. So this is an interesting article. You can click view, and this, because this is a preprint, is going to be completely free. You won't have to pay anything. This is TensorFlow Quantium. So this is the Quantium aspect of TensorFlow. You know, if this is such a niche aspect of work, of coding work, you're no longer talking about preferences of computing language. There's not many organizations that they can do this. So you need to adapt to whatever is there. So TensorFlow, PyTorch, doesn't matter. Don't politicize coding. So here we are. This is a long and interesting paper that you can read with very few images, but it explains how does it work, how you can evaluate the quantum model, how you can prepare the data set, evaluate the model, sample and evaluate the classical model, and evaluate the cost function. So that's all over there. It has some other interesting diagrams with spheres explaining how it operates. It gives you snippets of the code, which I have to say, it's not usually common in academic papers. The coding is usually in GitHub repositories or guidance documents. So this is an actual paper from the archive. So that's archive, and it's using code just because it's a very niche code. Usually we use pseudocode for this. We don't include actual code in journal papers. So here we are. That is the paper on TensorFlow Quantium, completely free. You can read this in your own free time. I'm not gonna. It's gonna take a really long time to explain this. What every single formula means. If you understand it, you would see it and you know straight away what does it mean. If not, stick with me until the end of this video, and you will know how to. I would explain it differently, not with the formulas. So I'm closing this. There we are. TensorFlow Quantium is a library for hybrid quantum classical computer. If you're using a coding environment, you just need to copy and paste the code. Usually you have video different descriptions here of how does it work. Those are by sometimes by technical people, quite often by non-technical people. So they explain it in non-technical language. That's very useful, actually. So there we are, TensorFlow. Amazon. Moving on to the Amazon supported brackets. So here we have regions and devices that are supported by Amazon bracket. Okay, there's a PDF that you can click, download, and read. We're just gonna look through the devices here and the gates based. So the device name, ARIA, ION, type, QPU, in what regions you can access them. So this is the European Union North, US East. Different regions would have different access to different, device names. So you can scroll down here and find all the devices that are available to you. You're going to get instructions on how you can import, and from bracket devices import. It's really not that difficult. Once you start getting your head around it, you just code that you import into your operating environment. So when somebody tells you that quantum computing, we don't really have quantum computers, well, that's not correct. We don't have powerful quantum computers. We don't have them at sufficient number of qubits, but we have quantum computers. And actually, I showed you can have access and you can play with one for 10 minutes for free per month. This is from Microsoft Learn. So it's a quantum computing providers on Azure Quantum. So here is the list of providers that would operate on Azure Quantum, and this has a description of what they can do. So Pascal, neuroatom-based quantum processor operating at room temperature, have long coherence time and impressive qubit connectivity. The operations are performed with optical tweezers. So this is explaining what it does. So different providers, IonQ. So this is a gate-based quantum computers provided, universal and dynamic, reconfigurable in software, providing up to 25 qubits. Be careful with those 25 qubits because quite often those are support qubits, so there's not the actual 32 qubits in low IO Forte. All qubits are fully connected, meaning you can run 2 qubit gate between any pair. Okay, so you want to play with it, this is it. Qubit availability, so here it lists you how many qubits. By the way, if you don't know, this is a quiz. How many qubits do you need, operational qubits do you need to have to break RSA? So current encryption is based on RSA. You need around 3,000, 4,000 qubits. And how many qubits do you need to break Bitcoin algorithm? Around 6,000 to 8,000 qubits. So this is far below that. But it doesn't mean that we don't have quantum computers. It just means that they're not powerful enough yet. But there's loads of people working. We've seen IBM, we've seen Google, we've seen Amazon Web Services, we've seen this is Microsoft. So this is quantum dominance, the landscape. So this is another article from the actual company. Let's see what did they promise in 2020, that they're gonna have increased the quantum volume of measure of computational power by 10x per year for 5 years. So here is they're announcing that they have model X2 that reached quantum volume of 2 on the power of 33. So providing not just what we always said, but our quantum computers are leading in the world forward. Yeah, again, be careful when they say these kind of claims. Obviously, these are companies that they need to make money and get money from investors, and they're doing excellent job in their quantum. I'm not criticizing them. I'm just saying we're not there yet. So when they're using this kind of definitions, we only need 3,000 functional qubits to break RSA, and we cannot break it today. So yeah, just something to think about. But here's a definition of why this quantum is better than the rest. So it's here on the table. So clearly they have sources that you can check here to benchmark that. It's defining the different types of qubits. That's the important thing, because not all qubits are the same. The architecture, fixed to grid, and then the identical qubits. So this one has it, that one does not have it. Okay, so this is a comparison table of the quantum volume as well. 2 qubit error rate is listed here. So this is an interesting paper to read on how they are the best now. Okay, let's look at another. This is again very recent papers from 2025. So we are going through the recent updates, because if you read the paper that I explained in the section 1 or section 2 that they're from 1988 or 1995, they might not be as up to date as these papers. So now we're looking at the quantum volume that is listed here, and again we're getting the same information that we have already covered. So we're going to close this one. We have another Amazon bracket article. So here we already spoke about Amazon bracket, but it's just mentioning it again in terms of use cases. So you can research quantum computing algorithms, you can test different hardware, you can build quantum software. So you can get a list of all the customers that they're using Pascal. Those are the providers in VN, and then somewhere over there is going to be the other ones that we mentioned. So they're kind of the same. So there we are. This is the article on what Amazon Web Services is currently doing. Here we have comparative study of that word is very difficult to pronounce, but it just refers to if you're trying to start doing something. This is the first step of the approach. So that's what that word means. It's giving you the first step of your research methodology to apply quantum large language models without trying to pronounce that word, which I cannot pronounce, Anastas or something. So you can read this paper again for free because it's on Archive, so it's a preprint. Just let's open the document just to show you that you can read it. I'm not going to read the paper. That's going to be really long, but it has some images and some diagrams that would make the quantum circuit easier to understand. So the string diagram and the memory diagram, that's all there. It has some comparison analytics and loss and accuracy of the training using the Ritter, Spider, and Tensor respectively. So different approaches. So there we are. We're going to close this one. This is another article that you can read completely for free. And let's look at this case study from Pennyline. This is protonic quantum computers. Actually, there's different types of quantum computers. So this is one type. So here you have the actual code, and you can start applying. So this is more relevant for me because I always look at things that I can apply in practice as opposed to things that I can learn about, and it's going to show you what you can expect to get from applying that code. And here you have a little bit more code, and again, you're not going to find much code of this kind in academic papers. We use pseudocode. Pseudocode is universal for every programming language. Here, clearly, this is a specific computer language that is being used to write. And some people don't like it because they might have preference for different programming language, and pseudocode would enable them to use it. But for me, this is more useful because I can just copy and paste and start playing with it. Actually, if you've never done coding, if you're starting to learn now, just one hint, nobody cares how nice and polished is your code if it doesn't work. You have to make it work, and nobody produces the best quality code. There are different techniques that you can apply to secure your code, like Snook, Deep Code AI, so they will be running analysis of your code and looking for vulnerabilities. I have those all recorded in my channel. I'm not going to repeat them here because the video is going to get too long, but there are solutions that you can run to ensure that your code does not contain vulnerabilities. So you need to start playing with it and doing it as opposed to just thinking about it, and the best way to do it is just copy this. So you click here, you copy the code and paste it in Python, and you start working VS Code with agentic mode. It will start self-correcting. There we are. Then we have NVIDIA, CUDA-Q. So even NVIDIA is working in the field of artificial intelligence and quantum computing, and as you can see, we have the same names. So those are the same that we have seen in Amazon Web Services. Continuum, that was the one that we were looking just now. So all of those we have already seen, and towards the end of this course, the names will start being familiar. That's the whole idea, that you start with no knowledge and gradually you build up the knowledge, and by the end you're gonna know what each company does and how they are uniquely positioned. So NVIDIA, by the way, works with artificial intelligence. They build chips for AI, and now they're looking at quantum processing units for agnostic platforms. This is the Q if you want to read the documents. So you have the entire documentation here for C++, for Python API, and for quantum operations. Then you can also get the NVIDIA Q GitHub repository, and here you can find a lot of the code in Apache license, open source basically. Moving back to the Amazon Web Services, they have something from December 2024, again about Amazon Bracket. So we have already spoken about Amazon Bracket, and we have spoken about NVIDIA Q. Now, as you can see, they are also working together. And here there's there's a description of how Q operates with Amazon Web Services. And again, you can see exactly the same providers, Rigetti, Iones, so those are same names. And here you get a different simulator, giving you for CPU and for GPU simulations, and how do they perform the benchmark. Obviously here you would say execution duration in seconds. So clearly, as I said before, every company would have their own version of, so this is the NVIDIA, this apparently it's the lowest, this is the Google that we have seen, and that's again the Qiskir, that is the one, the IBM. So we have, this is the one that we have seen with IBM, that's from Google, and that is NVIDIA. Is this test correct? Of course it is, otherwise they would not publish it. If you change the parameters, is it going to be the same? Probably not. That's why different companies would have their own versions of a diagram, how they perform the best in a specific function. So, and it's not lying, it's correct, it's just that you have to understand what do they do. So here is more code that you can just use. This is a Python code, as you can see there. So if you have Python, you can start playing with this. Another thing, Q, this is, we have mentioned IonQ quite a lot. So this was used in Amazon Web Services, in NVIDIA, and in various different examples that we used. So this whole documentation and explanation of how to set up your environment for Q, just simple function import. So that's it. Everything is very simple actually. You just import those things and you can use them in your environment. Now finally, Rigetti. We have mentioned Rigetti a few times, so let's look at what is Rigetti. This is a quantum cloud services. So you can use it with Python library, Q computer, and you can use it as a virtual machine. And are these companies going to remain the leading companies in the world? Quite likely, because they are breaking in very early. But again, in the world of technology, nothing stays static. Many organizations, they just vanish with time. Okay, I'm going to stop this video now just to make sure that we have short videos and that we cover specific subjects. So in this video, we have covered the overview of AI and quantum computing, talking about NVIDIA, Amazon Web Services, Google AI. So we have related this specific to the AI now. You can watch some of the earlier videos unless they pop up on the basics of quantum mechanics and quantum computing and the differences between classical and quantum computing. Again, this is just 15 minutes of my course with Pearson's and O'Reilly. Just the preparation that I'm doing. Actually, it's going to be a few hours just to prepare these 15 minutes, and this is why people actually subscribe and join. If you have free subscription, you should definitely use it. There's a lot of preparation going into delivering a good lecture that is going to have demonstrations and not just PowerPoint slides and bullet points. If you want to demonstrate how something works, you have to prepare it in advance. Again, this is in 2nd of September. If you miss it, then you can just go to the search and find whatever course I'm doing then and join for the next course. Hopefully I'll see you, and if you don't have subscription to O'Reilly, sign up to the YouTube channel. You're going to get everything as a notification for completely free. I believe education should always be free, but if your organization has a subscription, clearly this is going to be a lot more polished version than the YouTube version that I'm going to publish, which is my preparation. So 15 minutes could be expanded into an hour on YouTube, and I'm going to choose the best parts and put them into the course. See you in the next one.